Hi, Eric.
Hi, Vanessa.
How's it going?
I hear you did a wonderful job at the Brooklyn Podcast Festival.
It was me, Emily, Karim, Willa, not all, but Kara was missing, but she was in the audience.
Great.
Who else? Ryan wasn't there.
Many of the stars from season one.
Exactly.
Okay.
Many. And it was great. We had a packed space in Industry City, and we had really enthusiastic people in the audience. Like tons of people came up to ask questions at the end. A lot of like urbanism and mobility nerds, which was great.
Did they miss me?
You know what?
I know they didn't miss me.
I didn't hear any questions about your absence.
That's not what you're supposed to say. Okay.
It's like they didn't even care. But they're really into Willa and her transportation knowledge. We even talked about foamers.
Willa brought up foamers.
Karim brought up foamers, funnily enough. This is an inside joke. You have to get to the end of the podcast to understand what we're talking about, guys. So.
Willa's rubbing off on Karim.
Yep.
That's dangerous.
And we played the recycling game.
You actually played a game?
We played a game.
You mean the one that I failed when Emily...
Yes.
Yeah, okay.
I also played that clip. So just to hammer home how little we know. And just to laugh again.
You mean how much we're learning?
Yes, how much we're learning. That's a good way of putting it. So I think that's it. I mean, I hope people enjoy it. This is a little bit of a taste, a little teaser, a little amuse-bouche as we wait for season 2.
Or is it dessert for season 1?
Or is it dessert for season 1? These are the questions. I guess it's more dessert for season 1.
It probably depends on your philosophical view on life.
Thank you to City Farm Presents for inviting us to the Brooklyn Podcast Festival. Thank you to everyone who came.
That was really, really special. Our first ever live event happened, so that was exciting.
I heard nothing but wonderful things.
Yes. I'm glad to hear it. Hopefully, maybe we'll do it again. That would be great. Oh, we should probably say we have a new email address. We have the podcast at sidewalklabs.com email address. So if you want us to come to your city, I can't guarantee that, but let us know.
Or if you just have a great idea about an innovation on your mind for the future of cities.
And for season 2, because we are hard at work. Well, we will be hard at work. We're taking a break right now, guys. But we will be hard at work figuring out what's up for season 2. We have some ideas, but yeah, we're totally open to audience feedback. Let us know.
And with that,
we'll see you in the future.
All right. Hi, New York City. Thank you guys for coming to the first ever City of the Future podcast event. It's amazing that all of you came in this really cold day to talk about cities and their future and meet some fine folks from Sidewalk Labs. I'm Vanessa Quirk. I will be moderating this discussion. I am an architecture design journalist, and I've been with Sidewalk Labs for about 1.5 years. We are an alphabet company. We were started in 2015. Our mission, and I will read it so I don't mess it up, is to combine forward-thinking urban design and cutting-edge technology to radically improve urban life. And so I think what's interesting about Sidewalk Labs is that I think a lot of people assume that it's all just technologists, people that came from Google, and we have a couple of those. But we also have a lot of people that come from different parts of the urbanism world. We have civil servants. Our CEO was deputy mayor under the Bloomberg administration. That's Dan Doctoroff. We're an interesting mix of folks that have gotten together with this mission to improve quality of life in cities. When I was hired about 1.5 years ago, my boss, Eric Jaffe, a very talented writer who used to head up the New York Bureau of City Lab, actually. He and I were saying, hey, you know what would be great? A podcast. And I said, absolutely, let's make that happen. We started brainstorming what this thing could be. Next slide. Yeah, so I had to get crafty. So this is just a little behind the scenes of how this podcast gets made. This is a picture of where we record this podcast. So that is just a booth in the office that I and my colleague kind of stuffed with foam. And that is another room in Toronto that I just put foam blocks around and then hid inside. So this is we're kind of making it scrappy, but we're making it work. I did want to take a moment to just introduce our Toronto project for folks that might not be too knowledgeable about this yet. So I'd say the project that Sidewalk Labs is most known for kind of pursuing or planning at this moment is a site of land southeast of downtown Toronto. So you can kind of see there. It's mostly parking lots at the moment. And that's kind of what we've spent the last year or so kind of working towards internally. We've been doing a lot of public engagement events with the people of Toronto, trying to figure out, okay, what the heck is this thing gonna look like? Oh yeah, and then just a few weeks ago, we did announce kind of a draft initial site plan for what might end up being there. And so this is just to kind of give you a little idea of what we've announced so far. You can see all the buildings there are mass timber. We're kind of proposing that this site be the largest mass timber development in the world. So this will be a very good segue into talking to Karim, because he's our guy who's going to kind of explain what that innovation is, why we are interested in it. I'm going to play a little clip from our episode.
Mass timber started in the 1990s in the timber regions of Austria and Switzerland. Karim recently took a trip there.
And we went all the way up to this region of Innsbruck because there's a construction company named Romberg. And they're very, they're deep into their industry, I would say. Yeah.
Like, just like super nerdy about it, you mean?
Really nerdy.
The folks at Romberg took him out to one of their buildings so we could see mass timber in action.
And so we drive up to it. High hills, steep hills, and lots of snow. And so you have this view of a rectangular building sitting over the water. And part of the building is actually on stilts. So it's actually almost cantilevered into this reservoir.
And we assembled the building in 30 days, working days, in 6 weeks.
And you walk up, and of course you're greeted by 2 giant wood doors. And as you look around, everything has been done in wood, almost everything, I would say. The staircase was made out of wood, the floorings in wood, the ceilings in wood.
Nice, really nice space.
And then you have a 270-degree look across the lake.
Big, beautiful windows, man. Wow.
It was kind of breathtaking, actually.
If you go higher, this tree system is designed for multi-stories.
It's really,
You can build 3-4 stories.
really nice.
You couldn't walk into this building without a smile.
These buildings are beautiful.
Yeah.
This isn't a big, tall, spectacular building. This is a 5-story building that feels spectacular, right?
All right, so I'm just gonna start off with a pretty simple question. Would you mind just kind of introducing yourself, giving folks a little bit of a background about how you got to Sidewalk, what you were doing before then, and then we'll kind of get into mass timber.
Yeah, so I studied mechanical engineering. I got out of school and I got 3 job offers in the nuclear industry. I ended up taking one of those. And about 5 years into it, I said, this is all wrong. So my wife and I joined Peace Corps, and we decided to kind of reset our time, and especially my career. And I came back out doing buildings and water and wastewater systems, really on a global basis. And somewhere in '97, I really got very specifically into buildings, and ever since then, I worked on them, mostly hotels. And so I spent about 20 years with Marriott working and innovating their building systems and how to build even greener buildings and modular buildings. And one day Sidewalk called me up and said, hey, why don't you come over here and see if you can do some of that with us.
So I read an article that came out in Canadian Architect this week, and it said that you kind of were quoted as saying, like, you've been wanting to make 6, 8 beyond story mass timber buildings before, and this was kind of the first time that you'd actually been given the opportunity to explore that. So can you explain why were you interested in this? How did you hear about mass timber? Maybe also explain what is it for folks that aren't too sure. But yeah, how did you learn about it, and why did it excite you?
Yeah, so the first time I really got involved in it was I met a company in Europe. I was working in Europe from 2003. And there was a company that started to build buildings using slabs of mass timber. And mass timber means it's not just a raw piece of timber, but it's actually engineered timbers. It's sliced in about 1-inch pieces and glued together and given special structural properties. And they were able to get up to 6 and 8 stories. And they were assembling buildings, let's say, these were hotels, maybe 100 hotel rooms in about 3 weeks. And the light bulb goes on, and I said, wow, you can do a really sustainable material, and you can really go fast. And then I was like, I'm all about this.
Can you explain why it's sustainable? Because I think some people would hear, oh, it's made of wood, but that doesn't, obviously you're cutting down trees. So can you explain why it is a sustainable material?
You get certified timber, and certified timber means these trees were planted and cultivated in a regime that is appropriate to sustain and actually sometimes grow forests. They're cutting down trees that are very young, actually 10 and 15 years, because trees grow really quickly at the beginning of their life, and then they start to grow slowly, not very different than you and I. So they cultivate them after that big growth spurt, and then they are cultivated to then generate these pieces of timber that can be glued together to create stronger pieces. So what's the sustainability of it? We all remember our photosynthesis in biology, right? They're breathing in CO2, and then they turn it into part of their fiber makeup. So they're actually taking CO2 out of our atmosphere, right? And they're holding on to it. If we let them fall and decompose, they begin to release some of that CO2 back to the atmosphere again. But if we take them and actually preserve them, and putting them in the building is the way to preserve them, we then are actually taking CO2 out of the atmosphere as we build with using this material. So that's very different than the other materials that we typically build with, which is concrete and steel.
Yeah, and we talk about that a little bit on the podcast, but I think the nice thing about this forum is that we can get a little bit more into the details, since on the podcast I try to keep it, light and moving along. But one of the things that I definitely got feedback on that people wanted to know more about was the fire safety part of timber, because obviously we stopped using timber buildings for a reason, hundreds of years ago. So before we kind of get into that conversation, and I know you have some interesting new things to tell the audience, but before we talk about fire, I do want to set up one clip from the episode. And to do that, we need to set up who Michael Green is. So would you mind explaining who is Michael Green and how you met him?
Well, first of all, I guess because I was following part of the industry, I knew of Michael Green kind of afar. So I had this admiration for somebody who decided in his career that he would dedicate himself towards a sustainable building material. And it's a little bit in the podcast, if you listen to it, he has a very touching story about understanding how glaciers are melting and trying to make sure those glaciers will be around for his children. But so I knew about him, and then I had this chance to go build tall timber, and they said, why don't we call Michael Green? And I was like, awesome. I was kind of starstruck. And it's kind of funny being starstruck with Michael Green, because he's one of the most approachable people on earth. One of the most simple and forward and available people. Yeah.
And he's an architect, and he has a great TED Talk. If you haven't seen it already, I highly recommend it. But Rob, would you mind playing this clip for us, please?
It's easy to design and build these buildings, and they're totally safe. It's easy. What's hard is to change the public's perception of what's possible.
More people are living in all-wood buildings, including skyscrapers made entirely of timber.
But critics worry timber buildings could go up in flames.
Some fire experts are raising alarms.
Wood could fuel an inferno that firefighters can't fight.
Critics say it's the towering inferno waiting to happen.
Everybody thinks they're the first person to come up with towering inferno.
Towering inferno.
Right, that movie from the 1970s.
It's out of control.
They think that's the funny first line, right? And some people get super angry about the idea of building a wood building. The emotional response is just sometimes just so strong for some people, right? And you just have to remind people how fire works. Yes, wood burns, but everybody knows that if you take a big log and throw it on the fire and take your match and try to light it, that you can't get it to start on fire. And so we find ourselves just telling those stories and reminding people of basic science a lot.
Okay, so I just want to get into this idea a little bit, because we kind of go through it quickly on the podcast, but Michael Green does say there, okay, if you have a big log and you put it on a fire, it takes a really long time to catch flame. So can you explain how that concept is still pertinent when you're talking about mass timber? Because it's not exactly obvious that it would be exactly the same, right? So can you kind of dig into that a little bit?
Yeah, so a polished piece of wood, like a log, a perfect log, doesn't really have its fibers available to oxygen to actually start to burn, right? You need some oxygen in there. So that's why if you put any of those logs on the fire or you never split it, maybe in the morning you still see it there and it's just kind of blackened and reduced, but it's still sitting there, and we call that char, right? So most of us know that you have to split a log, right? There's a lot of activity around splitting logs, and a lot of people put a lot of effort into splitting logs because you need that fiber to be available to oxygen to actually be able to catch flame. So when we engineer these pieces of wood, we do the same thing. We leave a polished finish on the surface. And because of the char, which usually goes, half an inch or an inch thick down on a log, The way to preserve the structural part of the timber is to actually add a char layer of timber on the top. So it looks like it's all wood and structural, but actually those outer layers are just sacrificial layers in case there would be a fire. And they can blacken just like that log in the fire, but you don't lose the structural piece on the inside.
And I know that you kind of had some news that you wanted to share about kind of new research emerging around this fire and safety testing. So do you want to tell us a little bit about that?
Yeah, so this is really exciting because we're going to talk about seaweed and eggshells here instead of timber for a second. But the other way to insulate these structural pieces is usually they put drywall on the outside, right? And that drywall then insulates the timber center. So we were thinking, what's a better way to insulate this than using drywall? Because drywall is really not a great sustainable material. We end up with piles and piles of it in our landfills. And then Emily can talk about exactly how much, but hundreds of tons would be created just in this project. So we found a substance that's been around for 1,000 years or more in Japan that's called shikui plaster, and it's made using slake lime and seaweed and eggshells. And they compress it at very high pressure and they turn it into basically a paste or a slurry. And we're coating our panels then on the outside to be fire resistant. And so we started to play with it and approach some companies that would do this with us. And finally yesterday, so this is really great new news, we put it into an underwriter laboratory test cell and to see if it would sustain a 2-hour fire barrier, which is the fire barrier we all need inside of buildings. And it passed. So you're the first time I ever said that.
I don't think I've ever heard a clap for seashells and whatever.
Isn't that awesome?
Ooh, good crowd.
You guys had no idea you'd be clapping for that today when you woke up, did you? But basically, this material, the real exciting thing is it's rated as cradle to cradle. That means it's created in a very sustainable way, but it also retires in a very sustainable way. So any remnants of this material, if you want to throw it away, you don't put it in your trash. You actually just mix it in your flower pot or mix it in your garden. So it's a natural fertilizer. So I mean, this is a really fascinating moment to be able to change something like drywall out of the waste stream and create something that we can use as fertilizer instead.
Okay. I wanted to ask you more stuff, but we've capped up on your 10 minutes. So I'm going to switch it. So if you guys have questions in the audience, just make sure to save them for the end portion here. But I would like to move on to Willa. Oh, Emily? Emily's next on the slides? No? Wait. Okay, we're gonna do Emily. Rob, we're gonna throw you for a loop here. Would you mind playing the Emily clip rather than the Willa clip?
Should we switch spots? I'm pretty warm here.
We have a paper bin, we have a plastic, metal, and glass bin, a trash bin, and the fourth bin is an organics bin.
So I just wanted to throw away my lunch, and now I'm really confused. This looks like an aluminum wrapper that maybe I would put in the plastic, metal, and glass slot here because it's kind of metal.
Right, and if that was aluminum foil that was just straight metal, then that would be true.
Okay.
But if you open up that little wrapper.
So I also have, my surprise was that I also had a little food in here.
Oh, well, there's multiple things that we need to talk about then, Eric. Let's first start with the fact that that's not metal.
This is not aluminum. So how am I supposed to know that?
I know that's really confusing.
Shiny.
It is a combination. It is a metal-coated paper.
Okay.
Which then renders it not recyclable, unfortunately.
All right, Vanessa's laughing at me, but what would you have done in this situation?
I probably would have put it into the metal as well. I would have made the same mistake.
Just without the tomato.
It's shiny. How does that not look like a metal?
It is confusing. That is not metal or paper, so therefore it is trash.
Okay. So that's a little clip that introduced you to Emily here. So would you mind just telling the audience who you are, what's your background, how did you get into waste?
Like everybody gets into waste accidentally. My background, I went to school for interior design and construction management. I was clearly confused which side I wanted to be on. And I started working in an interior architecture firm, was realizing that I was no good at design, so I was much more of the form follows function. And I really was interested in sustainability, so I went to a consulting firm for about a decade, working on anything from Brooklyn Botanical Gardens to the 40-story office tower that is the Goldman Sachs monster. So it's a gamut of the different types of projects I was working on. And then I decided to go into operations. I was offered a position as the sustainability manager for the Google New York City campus.
Which is really big, I presume.
It is very big. The 111 8th Avenue building is 3 million square feet, and then they have they just bought Chelsea Market, so I was part of some of the projects building those spaces out. So being a part of the operations process then basically told me all of the things I was doing wrong in my consulting world. Maybe not wrong, but design only gets you to a certain point, and then the real kind of meat and potatoes is during the operations portion. So it basically started me thinking, like, what could I have done better on the design side to be able to inform operations and make that role better? So then luckily Sidewalk Labs came about, and it was an opportunity for me to bounce back into the development side and start to apply those thinkings back in.
Mm-hmm.
So that's background. Waste, again, in operations, I was like, I'll start with waste because that's easy. We're clearly not recycling enough in this building, and started working with the actual waste haulers in the city to try to understand what was going on and just getting tracking, and that was hard. So it just started me down this path of, how do I get people to separate? How do I get the hauler to do the right thing, or to do the thing that I'm telling everybody I'm doing and recycle it? And it just became very apparent that this is a bigger problem than people are aware of. And it just, I like problem solving, so.
And that was something that I learned throughout the podcast. I think you were surprised by how excited I would get about, it's like, this is such a difficult problem. Oh my gosh, so many layers, because you could do everything right in your office, and then by the time it gets to the bottom of your building, it was all for naught, because they don't know how to properly put it in the right truck, or there's like a million places along the chain where it can go wrong, right? So I thought it was really interesting for me to learn more about it. And I also, just to maybe retroactively make myself seem less dumb in that original clip when I was so confused about recycling, I do want to emphasize that recycling is very hard. It is much harder than it should be. Obviously, it's site-specific, right? Every city has different rules, which is also part of what makes it difficult, because in one city it's one way, in one city it's another. So Emily did bring, something that she brought to Sidewalk Labs in like a general office chat was just a little game. So I'm just gonna play it quickly with you guys. Let's see if you're probably much smarter than I am, but here we go. Pop quiz, Emily, you wanna take it away?
Sure, yeah. So this is a carton of sorts, looks like a milk carton. It is coconut water. A, B, or C?
Okay, so for the folks at home, I'm gonna, A is recycling, B is trash, C is organic. So if you think it's A, make a noise. Okay. All right, if you think it's B, make a noise. Okay, trash is strong. If you think it's organics, make a noise. Okay. All right, Emily, teach the people.
All right, slide.
Ooh, A. The A's have it. It was recyclable.
So, and this is where, I'm not going to get into this in every single one, but this is because New York City does do this. A lot of cities don't. Cartons are not easy to recycle. They have to be taken out into a very specific stream. So they're not always the most ideal material, but it is something that can be recycled if the city that you're in does it.
Mm-hmm. Okay, what's next? Coffee cup from the Sidewalk Labs office. A, recycling. Okay, small support.
I love all of you so much.
B for trash. C for organics. Oh, I think it's because the cup is green, and so people are like, that's gotta be organic.
Yeah, okay, slide. And
it's trash.
So clearly not that much of a surprise. This is where things get real complicated. So yeah, everybody was right. There is no such thing as a thermally insulated recyclable cup. So coffee cups, just try to use your own cup if you can.
And the packaging is really important in here, because that coffee cup has a little leaf on it. It's very deceptive. You think you can surely do something good for it.
Exactly. And then we've got the coffee cup dress up, but maybe we just fly through this, but then you get all complicated and you have to start separating things out, which is Also, something that you should think about, if it's like the metal coated paper, if it's two different things, you have to try to take it apart beforehand.
Right. And just for the people at home, the plastic lid is recyclable, the paper sleeve is organic.
So this was designed for 6th graders, but it works really well for everybody.
Don't tell the people. You showed it to us at Sidewalk. Okay, never mind. Moving on.
And they all failed too. So this is just it goes to show that recycling is super complicated. It's different if it's at home or at work, because work has private haulers. At home, you're using the municipal haulers, is my assumption. So New York City has their rules and their transfer stations and material recovery facilities, and then your work has a different one. Mm-hmm. So just to make it more complicated.
So unfortunately, I took all of your time in the recycling game, but
that's all right.
We will get
fun,
back.
right?
You guys, I'm sure, want to know a lot more about recycling, so we'll get back to you. But now let's actually go to Willa. Do we have a Willa slide? Okay, we're going to use this one because the Willa slide went missing. But Rob, could we have the Willa clip, please?
Green waves are fun. So let's just talk about waves in general, right? So you can kind of picture a wave and it's breaking, as it rolls in towards the shore. And there's a surfer right on top of that break. And as long as he's riding that, he keeps going. But instead of a surfer, it's a car. And if a car was traveling at the city speed limit, they would just hit green light after green light after green light after green light.
So cool.
Yes. So you don't need any special equipment for it, aside from timing the traffic signal in such a way that allows that to happen.
And so with these new lights, you'd be able to create green waves in real time.
So it's not just for cars anymore. Like, could you have green waves for bicycles too?
Yeah, they're doing some of that in Europe right now. And the way that it works is you're riding along a particular bike route, and there will actually be a series of green lights that are moving with you. If you travel as fast as those green lights move, so you're always within that green band, then you are assured that you will never have to slow down or stop.
All right. Willa.
Hello.
Can you tell the good folks what you do at Sidewalk and what your background is and how you got into streets and street design?
Sure. Hi, everyone. I'm Willa. I'm the Director of Mobility for Streets at Sidewalk Labs. And I'm a traffic engineer. So I have in my life designed traffic signals and laid out the geometry of intersections. Also worked a little bit in parking pricing and congestion pricing, but mostly from a municipal background, city government background, and I worked at the City of New York and the City of Berkeley.
Mm-hmm. So, okay, you said that you worked with traffic lights a little bit before. So what did you know about traffic lights before starting at Sidewalk?
Well, about traffic lights, they're everywhere.
Yes, I've noticed.
Adaptive traffic lights in particular, which we talk about during the podcast, they're actually decades old. So if you've ever used a pedestrian push button, that's technically an adaptive traffic light.
Because it responds to the person who's there.
Exactly. So it's just a traffic light that's able to react to a real life condition.
Mm-hmm. And I remember something that got cut from the episode, but you told me about in Queens, there's a couple of old school traffic lights.
Oh, yeah. New York City has been really trying, I know there's probably someone from New York City DOT here, so I don't want to publicly shame you. But, the New York City has 80,000 traffic lights or something like that, a ridiculous number. And so it's taken a really long time to transition them all over to a computerized system. And when I was working there, I was working on a project, and Danny, who's the head of traffic signals, took me out to Queens, and he opened up a traffic light, and it literally still had the little mechanical gear in it. And I was super impressed. And I bet he just threw that thing out, but that would have been great to keep.
So can you explain when you said an adaptive traffic light could just be one with a push button, but when you're thinking of kind of cutting edge adaptive traffic lights, can you explain what those look like and what they do and why they're interesting?
So I think one of the most important things and what we're really focusing on now, and Ryan sort of talks about this in his section, is adaptive traffic lights have been around for decades, but what they've been focused on is detecting cars and then helping cars move better. And so what we've been trying to do is work on detecting people and bikes in a better way. Because right now, if you roll up to most adaptive traffic lights and you're a pedestrian or a cyclist, you don't exist.
Mm-hmm. Yeah, and we talked a lot about the green waves. You guys heard the green waves in the clip. So can you, when you're thinking about, what you're hoping for the site in Toronto, I mean, what are you thinking about it in terms of, will there be green waves? Like, what would you ideally like to see emerge there?
So I think the green waves are probably like a small part of what goes on in Quayside. Hopefully that backbone will be built on transit and all of that. But we are hoping to basically demonstrate to Toronto and to other cities that you can give that type of priority and that type of experience to cycling that is usually now given to cars. So, like we talked about having the cars not stop, let's have the bikes not stop. We talked about the cars going at a certain speed, like let's see if we can get the bikes up to a faster speed as well and really make them a competitive choice.
And I know a lot of people obviously are in this world are really wondering about what's going to happen with autonomous vehicles. What's the future of that? How does that fit into a city, especially if you're trying to design one from the perspective of putting humans first, pedestrians first, transit first? Mm-hmm. In your mind, what's the role that autonomous vehicles should play in a city that is supposedly for people first?
So I actually think that the AVs are really exciting. Mm-hmm. And I know that's probably a mixed opinion in here. I think what's exciting about them is that you can get them to follow the rules. So you could tell an AV, you could say, don't go above the speed limit, or travel in this 6-foot lane and don't move, or never stop here, or always stay more than 3 feet away from a pedestrian or a bike, always. And then if you can do that, you can sort of rethink how you might design a street entirely from like the very ground up, right? So if you were on a bike and you were confident that the car would never hit you, you just knew it, and you also knew that it would never go more than 10 miles an hour, like, why would you then constrain yourself to like a 4-foot bike lane? You could go anywhere in that street. Mm-hmm. And I think that we should start thinking about streets that way. Like, how can we actually take advantage of the AV to reclaim more of the street for peds and bikes?
Mm-hmm. And I think from what you're saying that there's like two important caveats to make, right? A, that the technology is advanced enough that it is very safe and that you have confidence in its safety. But B, you also said the speed limit thing, which is interesting. I mean, can you talk a little bit about when you're thinking of street designs for kind of maybe in Toronto, but just in general, kind of when ideal street design, what's the role of speed and speed limit in that?
So the thing about today's streets is we're designing streets defensively. Because we're having the street outside, like on 3rd Avenue, you have cars going 40 miles an hour, you've got bikes going maybe like 14 miles an hour, and then you've got pedestrians walking 4. And that makes people uncomfortable, right? Like, you don't want to be that close with that kind of speed differential. And so you try to separate them as much as possible. And that's why our streets have so much wasted space in them. But if you kind of think about it, like, okay, well, what if the entire street had the same speed limit? And maybe it was 5 miles an hour. And every cars, bikes, pedestrians all had to travel no faster than that. Then you can actually start to imagine those people mixing more freely in the street and being comfortable doing so.
Mm-hmm. Yeah, and I think one of the things that we talked about, we don't really get to in the episode, but we kind of get to it a little bit in episode 2 on the dynamic pavement, is this idea of could you use lights to kind of direct people? Can you explain, like, when we think about dynamic streets, what we're talking about?
Yeah, so dynamic streets, obviously you could use bollards or physical barriers. And that's something we are looking at, like, how do you actually separate the pedestrian zone from the bike zone from the transit zone? And so we've been looking at a couple of options to do that. One of them is literally movable street furniture, right? Like, can we put it on wheels? Can we motorize it? Like, we put some trees on like little robots and drove them around in Toronto. You can come and see that. But then the other is this idea of dynamically colored pavement. And so there are companies, actually in France mostly, I don't know why the French have like cornered the market on dynamic pavement, but it's true. And you can actually run a charge through a layer that sticks to pavement, and it can turn it either from like a really light gray to like a dark gray, and actually simulate pavement markings, like a lane marking. What that enables us to do now is actually move the curb lane in and out to widen and narrow a sidewalk. And so that gives us a lot more flexibility throughout the day to sort of say cater to cars during like a rush hour if we needed it, or bikes to a rush hour. But then in the middle of the day when there's more people, we can actually widen that sidewalk. And so we make the most of a narrower space overall.
Cool. Awesome. All right, so I'm going to open it up for a little bit of a conversation in between us here, and I'm definitely going to start with Emily because you did not get to talk as much as the other folks here. So I guess my first question for y'all is, what is an innovation that you've seen either in your research or in your work that you wish were just everywhere? And I would love for you to talk a little bit from the perspective of waste.
Yes,
if
of course. I think that's why I'm here today. It's interesting when we talk about innovation and you automatically go to technology, or like digital technology, I should say. I actually am very excited, and something that is around all the time is pneumatic waste systems. So these tubes that go underground, there's one at Roosevelt Island. This is like 40, 60-year-old technology, literally sucking trash through the ground. So that is one way of reducing the potential for contamination.
Wait, can you explain that? Why does it reduce the...
So if you're in a multifamily building and you go to the trash room and you have 3 chutes and you put it in there, as long as that person does the right thing, then it's going to go to the right place. It doesn't have to go through building porters or loading docks or haulers or all these kind of different steps. So
you're saying the tube takes it from your waste room to the facility where it's going to be...
Correct, like to a terminal location where then you also are reducing the amount of truck traffic that has to go to each of the buildings, and you're really just picking it up on the outskirts. So also garbage trucks are dangerous, they're smelly, they're just a nuisance. You don't have bags of trash on the street, which I think I heard somebody that actually enjoyed that on the last podcast, but to each their own. But in addition to having kind of the infrastructure and technology, like how do you start to like also digitize different points and start to get information back to the users? So get it to a terminal location, maybe take a picture of it. Now you know what the contamination, you can feed that information back. It's like using infrastructure infrastructure paired with technology for really data transparency and education.
And we talk about that a lot in the podcast. And we didn't get into pneumatic tubes, which would be a fun episode. And I think in Barcelona, I think the trash bins go directly into a pneumatic tube, right?
Yeah, absolutely. In the public realm as well. So everything you don't see the bags of trash everywhere.
What about Karim or Willa? Any urban innovations that you've seen in your research or your work that you think, gosh, why isn't this everywhere?
I guess for me, the innovation, but really having more timber spaces.
You're on this timber train.
Yeah, I am. So I was just looking around the room when we walked in, right? So you have a lot of really hard surfaces here, and then you have they're all accented really by timber. But imagine if this whole space was in timber. And I think what's really interesting, it's been known to help people feel better and think better. To be in timber environments, and they've done a lot of biophilic design principles are around this, and they've measured actually improvements in classrooms, children's behavior and learning, and in hospitals for people's healing. And so I really do think this one's really simple, and it's just really bringing those natural materials back into our lives again, versus back out in the forest somewhere.
What about you, Willa?
I think I'd have to go with something that's not really an innovation, but something that Europe and Asia does that we don't, which is just run streetcars like on the street and not have to like completely separate them away from everybody else. Like it's just they share the space with everyone.
And so, and I have a question. You're probably going to have strong feelings, Willa, but if you could rule New York City, what would you do? What would be rule one?
It has to be congestion pricing.
Oh, okay. All right. Support in the room. Say more.
I felt like I was in a safe space. Okay. I could feel that from this audience. So I was comfortable saying it.
Okay, can you explain for my friends who may not know, what is congestion pricing?
Congestion pricing is the idea that we treat the roadway space as a limited commodity that people should be paying for the right to use. And
it's been very controversial.
It's been extremely controversial. It led to like the darkest day of my professional career when that thing went down in flames in 2008. But that doesn't mean that the idea is a bad one, and it's still alive to this day, which means that it still has legs. And it is the answer to fix what is our problems with transportation in New York.
Karim or Emily, if you could rule New York City?
I would turn back time.
Okay. Okay.
And I would, Thomas Edison actually ruled the electric works in New York City originally, and New York was a DC powered city. Actually, the last building was just retired maybe in 2008, 2009. Another dark reason for that year, I guess. But I think DC's on a comeback. So, he lost because Tesla was doing AC power, which could transmit over large distances.
Nicholas Tesla, we're talking history.
We're talking about Nicholas Tesla.
Just to prime the audience.
Yeah. You guys don't all know who Tesla is? It's not a car guy, okay? But that was good for centralized power stations. And now we talk about microgrids and having power much closer to buildings and communities, and to be more resilient and all that. And so now DC comes back. And that's why I think if we went back to Edison's time, we would be really in a better place today. We could supply and create our own energy locally and consume it locally.
And thank you, Karim, for teasing season 2, because we're probably going to do an episode on that. Emily, thoughts? New York?
I mean, I'm a big fan of the DC power answer, but because I will stay on waste, I think single-use disposables, either having another opportunity to, I think New York City is really big to try something like Amsterdam, where you have a system where everybody uses the same, and then there's a city infrastructure that actually cleans and reuses those. Maybe that doesn't work, but that is a huge problem in New York City. Bags and to-go containers, takeout, Amazon packaging, all that stuff. So I think if you ask Andrew Winters what she would like a shout out, that edible packaging is really the way of the future.
You heard it here first. Edible packaging is the future. All right, well, I'm going to open up the floor. I think we have probably around 10 minutes, so come with your questions.
Hi, my name is Amy. I work with a nonprofit, and we track cities' climate action. And so one of the things that you guys mentioned was about AVs, but I was just curious about EVs, because cities have a really hard time financing that infrastructure because it's cheaper for a private citizen than it is for a city I work with to try and electrify their vehicle or kind of make it more accessible for their citizens to charge their cars. So what's your take on it?
Yeah, charging infrastructure is a big one for that one.
Yeah, you had promised me 100% charging, right, at all the spaces and parking in Toronto. I mean, I think that it's very important, and we are planning to have charging capabilities for every vehicle that enters the Toronto site.
Cool. Next question. Go for it.
Hi, I'm Jeremy. I work for Jet.com. And one of the things that makes me sad about my job is seeing all the boxes on the street.
Yeah.
So you mentioned that you would like to see or Emily mentioned that you would like to see a centralized way of reusing something. So can you think of any way that we can reuse like boxes that we ship to people? Does it have to be cardboard? Can we send some sort of plastic thing that gets picked up and reused over and over again?
Yes and yes. Because edible packaging is probably more difficult than
some people at Sidewalk would like to believe. Yes.
We have been kind of playing with this whole idea of this urban consolidation center, where if things are packaged and shipped and then able to come in reusable containers that maybe come to you, maybe they know where you are, maybe they don't. But then you're able to actually use that, like some kind of back channel method. So if you did have cardboard or oversized waste or whatever it is, that could then be also utilized to go back. So now you're also not wasting energy, like only not having the back channel opportunity. So yeah, it's super hard, and there's always kind of this line you're trying to toe between like privacy, because you don't want to just like unwrap everybody's packages and then like send it to them, so there's not cardboard everywhere. But it's definitely, there's opportunity for improvements there for sure.
For sure. Hi, what's your question? Who are you?
Hi, my name is Brian. I work for a nonprofit in tech policy. Specifically to Emily, I know the city has sort of overhauled their commercial waste plan. I don't know enough about it except for like the massive political fight between like the status quo and what's sort of changing. Can you just give a little bit insight of what you think about it? And sort of just as another for Willa, congestion pricing is something that's state of the state's coming up. I work with some of the groups in Transit Future and all that stuff. What do you sort of foresee in terms of what's happening with the state, and whether you think it's going to be possible in the next 30 to 60 days? Thanks.
I'll try to take, I think you're talking about the franchising with the commercial waste changes? Yes. Yeah. So just for those of you that don't know, that right now you can hire whoever you want to come pick up your trash. So there's garbage trucks kind of like going every which way. So they're thinking, New York City is kind of segmenting different zones out so that you can only have access to a couple haulers, so that it's supposed to reduce truck traffic. I have mixed feelings about it. I understand that it is good to reduce truck traffic. I'm not sure, based on the size of Manhattan, if it's really going to do that much. And I would prefer that they focused on contamination rates, education, and accountability, and actually charging people who aren't actually doing their jobs of recycling. So that's where I'll stop, so I don't get in trouble.
1 second. Sorry, just before the next question, Will, if you want to tackle the congestion pricing question.
Sure, the congestion pricing question. I mean, the big reason that we failed in 2008 is that it was a city-generated initiative, and the state refused to even hear it. And so I think that the way for congestion pricing to happen is for it to come from the state level. So I am excited about the possibility that the state of the state might include something about the governor proposing congestion pricing as a way for New York City to fund its subway issues.
Great. We're short on time, so if the three questioners can be quick with their questions, and we'll hopefully just wrap up with you guys. Go ahead.
You guys seem to be working on a lot of different things. I would love to get examples of your build versus buy kind of take. So how much do you partner with other companies, in what scenarios? In what scenarios are you like, no, this has to be in-house, this has to be our own lab situation?
I think it's a pillar by pillar thing, right?
Yeah, I would say that we share a philosophy, though, amongst all the pillars, which is that buy whenever possible. We waste time by building things that have already been built and done by other people. And so it's only when we see something that isn't done or isn't really done well that we would step in and develop it ourselves.
Mm-hmm. Or put two people together that are almost there. Yeah. Like right. A lot of partnering. Yeah.
Yeah, we do a ton of research, so we find that we actually know a lot more than people assume, so we do have that capacity to connect. Yeah, go ahead.
Hey guys, Mike Thompson, New York City DOT. Willie, you're right. I just want to say, don't feel bad about shaming the government or the DOT. In a lot of ways, you know, we all pay taxes, and because we pay taxes, we want good products and services. And when I was in your seat in the private sector, you know, that's how we got things done a lot with the government. So don't feel bad, and you know, just keep fighting. My question has to do with like technological innovation versus like policy innovation, and the congestion pricing, you know, is more of a policy. Is obviously a policy, not a tech. So I guess my question is it? Do we need policy innovation or do we need technological innovation more? And is there a relationship between the two that we can help you know, have a feedback loop and you know, to have something, you know, innovative like the congestion pricing? Thanks.
I think the tech innovation can only get us so far. One of the things that we like to see in our modeling is, hey, how much better can we do with like moving people if we are able to time the traffic lights right? And then what changes when we actually put in like say a $8 charge, right? And it's no contest, right? Like the $8 charge completely changes behavior, whereas we're sort of nibbling around the edges when it comes to sort of the tech innovation. Can they come together? I do think so, and this is actually one of these places where I think there's actually a lot of excitement around AV policy in particular, is that may be the place where we land congestion pricing first, in basically using pricing to regulate how many AVs are out there and how fast they can drive and how far they can drive.
Great, last question.
It's another question for Willa about congestion pricing. Sorry,
Whoa.
my name is
Hot
Bhargav.
topic.
Yeah. So the New York Times a while ago did a piece on the crumbling infrastructure in New York City with the subway, and found that some of the root causes were both political and budget. And so if congestion pricing were to be adopted, how does that affect the amount of people that will move towards mass transit, a mass transit system that is not going to be able to keep up with the current capacity as it is?
I mean, that's a great question. I think that keeps all the foamers in the room, like up at night. Just the foamers, by the way, is it's a term that to describe people who are like overly into trains. And
Foaming
it comes
at the mouth
yes.
about trains.
It comes literally from like when the first British steam engine was on the track, and there were people who came and they're literally foaming at the mouth because they were so excited about it, and so that is me, and people at work make fun of me about it. So I really can't really speak about the policy. Like we have policymakers and politicians and decision makers to do that, but we're already in a hole with the infrastructure, and really the only way to climb out of it is with better funding. And where does that funding come from? I think that there's a lot of ideas, but congestion pricing, it does have the capacity to generate so much funding for our infrastructure and for our subways that I think it deserves a serious look.
Okay. Thank you guys. Thank you all for coming. If you haven't subscribed to City of the Future, go ahead, give it a subscribe. It would be great. My sister has stickers for any City of the Future fans. So she's there in the lovely teal. So if you would like a sticker, ask her. And thank you again for coming. This was great. Our first show. Thank you. See you in the future.